All right, so let's talk about this one. Another small little detail here. Okay. All right, so this one it does specify which way to integrate it. We're going to do by all accounts here. We're going to do the y first. Now, that looks kind of bad, but that one's integrated with respect to y. It's not really that bad. Because I can think of it this way, which will be another point I'll make here in just a second. Okay. Yeah, it's just integrating y cubed, this first one, right? What have I got? 0 to 1, what's that going to be? This is just constant, right? It's just power. 1/4 y to the 4th. We can do that. Y equals 0 to y equals 2. Handle the dx here in a second. So if I plug in that, y is 2, we get 1/4 of 16, which is 4. The 0 gives me 0, so yeah. 4x, the way you think of it, 0 to 1, 4x over x squared plus 1. Yeah, and so we'll run into any and all of the, maybe not all of it, a lot of different kinds of our antiderivatives. What are you going to do there to do that antiderivative? What's the first thing you always try? U substitution. Yeah. Always try U substitution first. Just to remind you of that. Let's do it over here. All right, so U, let's let U be x squared plus 1. So that'll make du, the derivative of that will be 2x dx then. So the way we usually did it is we get the dx. That's going to work out pretty nicely. Because yeah, you got 4x over u, and then the du, substitute that for dx. Yeah, that's going to cancel that. It's just going to be 2 over u du, which, what's the antiderivative of 2 over u? ln? 2 times the ln, and the good news is it's technically absolute value of u, but in this case they're both positive, so u is x squared plus 1. So that's what I was saying. You don't really need the absolute values there because that's not going to be positive anyway. Yeah, so remember, go back. This is the antiderivative with respect to u, but these are x's. So go back to the original. U is x squared plus 1. So what does that give? Plug in the 1, you got 2 times ln of 2, and then plug in the 0, you got 2 times ln of 1, but ln of 1 is 0. So 2 ln of 2, or you could write that ln of 4, because it's ln of 2 squared. You can bring that inside there, so either one. Okay, now here's a little point about this. This one is different because here is another way we can do this. Turns out, all right, so this is my f of xy, right? Well, notice I can write it like that, or I can write it that way, which the significance of that is, notice I've got the x's and the y's separated. And so my f of xy, if f of xy equals, I can write it as one part's a function of x and then the other part's a function of y, you know what I'm saying? This is my function of x, this is my function of y. Here's what you can do. If you can do that, then and you're talking about a rectangular region, and we're integrating, so there's a second part, and, because we'll talk about a non-rectangular region next time, but, and we're integrating over our is a rectangular region A to B, like C to D, X is between A and B, C is between C and D. Rectangular region. Then here's the kicker. You don't have to, but here's what you can do. Then the integral A to B, the double integral A to B and then C to D, f of x, y. That's dy dx, or, and it could be vice versa there, but you can do it this way. You can do this by doing the integral from A to B, g of x dx, times the integral c to d, h of y dy. See what I did there? So instead of having to go do the y integration first, then the x's, if you can split the x's and the y's up, you can do you can kill two birds with one stone, as they say, or do it all at once. Instead of having to do, well, let's do the y's, then do the x's. If you can do it this, if you can break it up this way, and it's over a rectangular region, maybe save a little bit of time this way. So notice here on ours, all right, so what we're saying is on ours that we had 0 to 1, 0 to 3, 0 to 2, and then we had x over x squared plus 1, and then times y cubed. And we had a dy dx. What we're saying is we could have done this. X is 0 to 1, so do those, the x parts there. And then times by the integral 0 to 2 of the y cubed dy. Split it up. Yeah, because this becomes, that's our u substitution. Well, it's a little different, isn't it? This would be, so u equals x squared plus 1. The du is 2x dx, so d over 2x. So it is a little different as far as the u substitution, but let's see, what would that give me? Integral, so it'd be x over u, and then d over 2x, so yeah, you'll have a half there. 1/2, so it'd be 1/2 ln of u, or 1/2 ln of x squared plus 1. And that's from 0 to 1. Okay? Which is half ln of 2. Okay? So that's this part of it. Now, what we're saying is we can multiply it by this one, which would be 1/4 y to the 4th, from 0 to 2, which is 1/4 of 16, so that's 4. So if I multiply these two together, don't I have 2 ln of 2 or ln of 4? Ta-da. Okay. But that's only in that special case. The previous one, like what I have earlier, I had it was 0 to 2, negative 1 to 1 was one of the ones I did, 100, 6x squared y, dy dx. All right, so this doesn't pertain to that because I can't split up the x's and the y's here. I can't do it function of x times function of y. I can't split it up like I did this one. Okay. So it doesn't always work. It only works in ones like we had this example. All right. Any thoughts or concerns there?